Welcome to Understanding Rack here on Tekpub. In this screencast, I am going to show you Rack, the framework's framework built on Ruby that allows you to build up your very own Ruby web framework, and a whole heck of a lot more. There's a lot of code to this, so I'll do a small introduction to show you what Rack is all about. Then I'm going to jump right into extensive amounts of code. Be forewarned, you should be familiar and comfortable with Ruby. So if you dabble in Rails or Ruby, there's no doubt you've heard of Rack before, perhaps hearing that frameworks like Rails and Sinatra are now Rack-based. This might seem a bit confusing at first. I mean, what the heck is Rack, and why would Rails or Sinatra be Rack-based? What does that mean? Well, have no fear, it's why you're here at Tekpub, so we can explain these things. So Rack powers web applications. That's the explanation you get when you go to the Rack website. What does that mean exactly, and what does it do? Who made it? What does it mean to you as a developer? Well, the short answer is that Christian Newkirchen developed Rack back in February of 2007 as a tool for framework developers to use, giving them a way to stop stressing over the low-level stuff, the parsing and handling of HTTP and other things. As Christian puts it, framework developers were spending a lot of time doing the same mundane work, low-level web transmission stuff, and not writing the code that inspires them. So he built Rack. In the simplest terms, Rack sits right between your web application, which can be Rails, Sinatra, Camping, or your own creation, and the web server that runs your application. In essence, it handles the mundane communication details so that you don't have to. But as you're about to see, it does a lot more than just the low-level operations like parsing HTTP. It also exposes a drop-dead, simple yet powerful API that you can pick up and work with as you see fit. You can also include Rack modules as needed. Things like request, response, URL map, session, logging, authentication, cookies, and exceptions. It's almost as if you were to rip HTTP context out of ASP.NET and say, here you go, Merry Christmas, have a nice day. Well, if you are a .NET developer, you might be thinking, hey, well, this sounds an awful lot like an HTTP handler. Why should I care? And you'd be right. Well, the difference is that Rack isn't reliant on a server, unlike HTTP handlers, which rely on IIS routing a request to the ASP.NET DLL, which then hand off the request. Well, nothing explains concepts better than code, so let's jump right in. Understanding Rack is pretty straightforward once you see it in action, and so let's do that now. And I'll do the typical Hello World demo, and we'll create our first Rack application. I'll be working on my Mac today, but you don't need to have a Macintosh in order to use Rack. You can do it on a Windows box, and I'll walk through the installation in just a moment. All right, so to get started, what I'm going to do is to open this directory up using TextMate. There it is, and I got my Rack directory on the right here. And I'm going to create a file, and by convention, I'm just going to call it app. If you only have a single file in your application, well, app is pretty much a good name to call it. The extension is .ru, because we're creating a rackup file. It's kind of like startup rackup. You'll see in just a second why I called it that. All right, so I'll hit create. Inside of here, I'm just going to create a simple class, and I'll call it Hello World. And inside of here, I need to have one method. If this is going to be a Rack application, you have to implement one single method. That method name is call, and call has to accept a single argument of environment. And we'll talk about what comes packaged in that in just a second. What call needs to return is an array, and that array needs to consist of 3 elements, and the first is a status code, which needs to be a string. So that could be 200. If I wanted to create a special application here for things that aren't found, I could return 404. The next thing needs to be headers. And so inside of here, I can add a simple header, and what I'll do is I'll just say content type, and then I will tell it that this is going to be text plain. Okay, if you're wondering what this construction is right here, this is called a hash using Ruby. And a hash, if you're a .NET developer, C# developer, you can think of as a dictionary. It's just got a key and a value. So in this case, I created a key-value pair of header information for content type. Well, the final thing is the response. So status, headers, then response. And that response object can be anything. It just needs to respond to a certain method called each. I'll talk more about that later on. But for right now, what I could do is simply put in a string, and I'll just put in, can you guess? Hello world. Okay, well there is my rack application, hello world. It's returning 3 things: status, headers, response. Okay. Well, let's tell rack to run this thing, and we do that by issuing the run command, as you can see, hello world.new. There we go. All right, that's it. So let's run this thing and see how it looks. We'll head back over here to our console. So what I need to do is to tell rack to run this application, app.ru. We're in the same directory. You can tell ls, there it is, app.ru. So I'm going to say rack up, and this is a call to the rack up executable. What this is going to do is take my code that I just wrote. It's going to go find a web server for it, and it's going to make them hold hands in harmony. Rack up app.ru. I'm going to tell it to run on a specific port, 9000. Done. So what just happened? Well, rack said, well, all right, what's in here? Let's take a look, and found a class. Said, okay, I need to run this thing. Does it respond to call? Why, yes, it does. Great. Okay, so I have a rack application. Hey, where's the web server on this machine? It went and found a Mongrel, which I have installed. And now we're running. That's great. All right, so now let's pull in a web browser. And here we go. Pulling it over. And so now, if I go and browse localhost, go to 9000, there we go. Boom. Hello world. There it is. Pretty simple. Installing rack couldn't be easier, and we'll start today by installing Ruby. And you want to make sure you install Ruby 187 or 186, either one, using the one-click Windows installer. Now, if you're using a Mac, you probably already have Ruby installed, so no worries about that. The next thing, if you're following along on a Windows machine, you want to use eText Editor. That is going to be as close to a TextMate experience, which you're going to see me use, as you can possibly get. And if you don't have that, you can also use Notepad 2 or Notepad++. What we're doing doesn't really require an IDE. It's just all going to be Notepad-y kinds of things. And finally, to install rack, it is simple as saying gem install rack, let it run, and you're all set. Now, it's worth noting at this point that if you already have Rails installed, and it's a recent release, 2.3 or greater, you already have rack. So there's nothing you need to do here. If you already have Ruby, you already have Rails, there's no installation necessary, and you can kind of just skip over this part. Well, Hello World demos are fun, but of course we need things to be a lot more functional than this. And for them to be more functional, we have to have, well, more functionality at our fingertips. And so one of the keys that we're missing here is this environment variable, env. And what's happening here is that rack is passing in the environment information. Now again, at its core, rack is simply an HTTP parser. And what it's doing is kind of listening to the request coming in over TCP/IP, parsing out the values, and then, well, handing it to our application so we can do something with it. So to understand what's there, let's squeeze some information out of the environment variable. And what I'll do is I'll set up an output variable here. And environment, well, simply is a hash. If you're a .NET developer, it is a name value collection or a dictionary, if you like. So what I can do is I can loop over the keys, and I can say each. That's it. So then I can now put this right here. Okay, so now we should be able to loop over that env variable and see what's going on. So what I need to do in order to get that to work is I need to actually stop and restart our server. I hit Control-C and then up arrow to do that. And I'll come back over here to our browser. Hopefully if I didn't goof up my code. There we go. All right, well that looks kind of yucky. So let's really quickly drop in a line feed right there. Now this is, again, being served as text plain. So the browser is interpreting it as text, and so it's applying those rules to it. And of course I don't want that there. I want that right there. Okay, so let's go back and we will restart our web server here. There we go, running on port 9000, and let's refresh this so it's a little bit more readable. And as you can see, look at this. I have got all kinds of information handed to me, very web server-y stuff, things that I can use. and ask for. I can say, what's the remote address of the user, env. So if you're a .NET developer, you can look at this and say it's HTTP context. It's got all the kinds of stuff that we want in there. It's got access to cookies and scripts and so on. But how does it know all this? I mean, how did it do all this? Well, the answer is that it uses little rack applications of its very own to create and squeeze these things out. We'll talk more about that later on. All right, well, that's env, but man, this looks ugly. Is there something we can do about this? Well, of course, we are working with a browser. This is very, very low level. So what I can do is I can come in here. Instead of doing a carriage return, what I might want to do is to simply pop in a list like that. And instead of text plain, I could just set it to be text HTML so the browser can interpret it properly. All right, once again, I need to hit Control-C. All right, and we'll refresh this. Woohoo! All right, well, now we have HTML. But as you can imagine, if we view the page source, it's just straight HTML. It doesn't really say much of nothing. It's okay, we'll fix that soon enough. Well, while we have this open, let's take a look a little bit more at what the environment variable gives us. And if you're familiar with server variables in ASP.NET, we'll take a look. This looks awfully familiar. You've got path, user agent, host information, protocol, server software, path info, remote address, and so on. So that's all the server variables that HTTP hands you. But you get a little bit more than that too. Notice you get rack version, you get rack errors, URL scheme, multi-process input. You get a lot of extra information that rack itself is parsing out and giving to you. So we're not just stuck here with straight HTTP that we have to then interpret. We don't need to necessarily take the straight HTTP variables that are handed to us and then say, okay, well, now what do I do? Rack can actually intercept these things based on the modules you choose to use. We'll talk more about that in just a bit. Our little demo here actually turned out to be somewhat functional. And what we could do now is to sort of open it up so other applications can use it. Because right now, it's only a one-way sort of deal. The Hello World application gets called, and nothing else can really play with it. It doesn't seem very functional as an application on its own. However, if you were to combine this with other applications, well, that might be kind of interesting. So the way that we do that in Rack is to create a constructor, and it's called initialize. And so initialize is going to accept an argument, and this argument is going to be passed in by Rack, and that is going to be app. And app is going to be the application that's calling it. Simple as that. That application is going to be of type rack application. So, well, that's pretty much how that works. And we're going to default this to nil. Now we're going to allow for nil to be passed in because, well, as you can see right here, we don't have another application calling it. This is the top level application. So what we're going to do inside of here is we're going to create a class level variable. You do that by appending or by prepending, an @ symbol on top of the variable you're talking about. And what we'll do is we'll just set this to be app. Now we can use the app later on down here. Well, what we can do here is instead of just outputting our output, we can play nice. We can pretend that, okay, maybe there's other things that these other applications want to be doing. I am a link in a chain. So I could do a quick test here and I can say, let's not do that. Let's do a good test here like Jeffrey Grossenbach told me to do, unless app.nil. Should always test for the positive, according to him. Okay, so if it's not nil, what we want to do is we want to append its output into our output string. So, what we can do in here is, if it's not nil, we can use its call method. And so I can do that simply by saying @app.call, because remember, the application that's coming in is a rack application, and it's going to have a call method, because every rack application has to have a call method. Okay. And so what I need to pass it is, of course, the environment. Well, what I'm going to get back is an array, just like you see right here. That array is going to have a string, which is a response type, a response code, and it's going to have a hash, which is header information, and finally, it's going to have the response object. Now, this object can be anything, as I mentioned. It could be a string, it could be full-blown complex object, who knows. What I need to do, though, is I just need to kind of take that object and use it to my own devices. So what I can do here is I can simply just say response equals app.call. I don't care about the headers or anything else. I know this is a horrible thing, but right now I just want to focus simply on what I need to do, which is appending my stuff to the output. All right, so we're going to pull the response out, and then what we're going to do is we're going to append it append it on top of our output. There we go. And now we're good to go. All right, so that seems pretty good. Now let's also rename this. What we can do is just say environment output. Why not? Rename this class just so it's usable. And we're going to rename that here. Okay. Well, ideally, everything should work. And what I can do is come back in here and say rackup, and then app.ru, and then again tell it the port, and we're going to go 9000. So I'll run. Whoops, and I spelled that wrong. I do that a lot. I'm not sure why. I can't seem to manage to put a C in there. Okay, we'll go back to our application and reload it. And look at that. Seems to work. It's good. All right. So we're happy with that. But the problem that we have now is that we're going to be building this out a little bit more because I got more of a demos to do here, of course. And it's a bit of a pain to stop and restart this server. And, not that big of a pain, but stopping and restarting a server in order to see changes in the browser is, not very user-friendly. So what I'm going to do is I'm going to replace Rackup here with something else entirely. And as you can imagine, in the open source world, there's all kinds of, well, let's call them Rackup starters, call them whatever you like. The one that I really like is Shotgun, and we'll talk more about Shotgun later. But what Shotgun does is it manages restarting the server for you. So if there's any file modifications, it'll just restart the server, kind of in the background, and you're free to just change things as you need to. So to install Shotgun, you just say sudo gem install Shotgun, and I'm going to say no RDoc and no Ruby Interactive because I don't want to download all that stuff. I'm doing a screencast, time is money, all that stuff. So I will say go, and I'll pause while this thing loads up. All right, there we go. So it is installed. Didn't take too much time. So now what I can do is instead of saying rackup.ru specifying a port, I don't need to do any of that. What I can do instead is say Shotgun. Plus it's cool to say Shotgun. And then I can say app.ru. And that's it. And what it's going to do, as you can just see right here, it's going to look out and find a web server, and it's actually going to report back to me some more information other than emptiness, which is what Rackup did. And it's telling me that, hey, I started up Mongrel, and here's your port, 9393. Cool. All right, so if I go back over here and change my port, let's make sure everything's working. Well, that it is. That's good news. All right, so that's working nicely. Well, now, what other kind of damage can we do inside of here? One of the things that springs to mind is that we can try and make this play with other applications. It's nice to just have output here, but what if we wanted to chain in some functionality from somewhere else? Well, what if we wanted to turn our application here into what's known as middleware, something that you might use to plug into other applications, not really meant to run on its own. And looking at this functionality, of course, outputting an environment, well, that's really not meant to run on its own. Probably want to have that run as part of another application. So we can do that. So let's create another application. Why not? So what I can do is I can create a new class, and we'll just call it my app. And inside of here, we're going to do the same thing. We're going to put in a call, and it's going to accept an environment variable. And what I'm going to do now is I'm just going to copy this line right here. And we don't really need to worry about an initialize accepting in an app. This is the starting point, so I can assume that I can just leave initialize empty. And instead of this, what I could do is just put out a nice title saying hello there. All right. So instead of calling environment output not new, I'm going to output that. Great. And then if I come over here and refresh this, hello there. Shotgun makes this so nice, doesn't it? All right, so we have hello there outputting. Well, what if I wanted to use environment output as part of my app? I can. And the fun thing is, well, it's pretty straightforward. You just say use. And then you can say use environment output. Output. All right, we can spell that properly. So now that we've done that, we can, boom, see how our things now go together happily. And notice here that the response of the environment output was appended to the response of my first app. In other words, this application, my app, was passed in right here through this initialization, and it was appended right down there. You're probably thinking, as you're looking at this, that there must be a lot more going on than just a simple matter of HTTP parsing, there's arranging and injecting and all those things going on in the background, and indeed there is. Let's take a little bit of a deeper look at rack. At its core, rack is pretty much just an HTTP parser that takes information from your web server and hands it off in nicely packaged ways to your application, and then accepts information back from your application and hands it off to the web server so it can serve it back to the browser. So given that, you might think that rack is a pretty low-level framework. But as you can see from our output here, there's a lot going on. It is a low-level framework, but it's got a lot of interesting things built in to take that low-level functionality and raise it up. So really, all you got to do is write a little bit of code, and you've got yourself your own framework sitting on top of rack. So let's take a look at this a little bit more. You can see all the information that I have at my fingertips. If I want to walk through URL information, post information, headers, all kinds of things, really. So taking a look at the source for rack, we come on down here, you can see it's not all that big of an application, really. And we can drop into the live directory and see what comes pre-built with rack. And drop into the rack directory here. And inside here, you can see there are a bunch of things that are already set up for you, which is pretty interesting. All of these, well, mostly all of them, are modules that are based on rack. And they pretty much exist to enable functionality at a higher level. And so if we hop on over to RubyForge and take a look at the RDoc, you can see in such a case, we have the request module for rack. And inside here, we have things like get, post, and so on that takes the environment and then it kind of squeezes it out into things that we understand in terms of cookies and gets and posts and so on. We can also take a look at response, which pretty much does the same thing. URL map, which is another one. Take a look at the source code inside of here. And these are all made possible by a thing called the builder. Now, if you've been watching me string these things together with run and use, and you're wondering what is run and use? Well, if we come down here and we take a look, you can see that run and use, right here, run, use, are defined on this thing called the builder. The builder is pretty much what makes your application run all together. So when you call rackup calls builder. Builder takes a look at what it needs to run, and then it kind of strings these things together and hands control from one to the next. So that is builder, and of course it itself is a rack application, which is pretty neat. It's kind of this recursive sort of interaction between all these elements that go together into this interesting fabric that can make up a framework. So, as you can imagine, people have gone, quite happily building these modules and little rack apps, kind of meant as middleware. And then you have rack contrib right here, as you can see. And inside rack contrib are all kinds of interesting things. And here's all the modules that you get. Caching, callbacks, config, lots of good things here. Well, of course, you don't just need to stop there. I mean, as you can see, these are all great little bits and modules for working in higher level frameworks, but you can do a lot more. You can build a pretty sophisticated framework on top of rack. You can probably take all of the methods that rack exposes on top of the modules. You can write your own and make a bit of a DSL so that you can respond to things coming in a much more elegant way than having to get down and get your hands dirty. But you put a DSL on top of rack and you have what's known as Sinatra. And I will be talking a lot more about this in a further screencast. Now that we understand rack a little bit better, you talk about Sinatra, well, you know what makes Sinatra run. All right, well, let's jump back to our example here and do a few more fun things. Tekpub web framework is coming together pretty quickly. However, it's far from being finished, and what I'm going to do now is to try and introduce a couple more concepts here that you can build on top of rack. Specifically, what I want to do is I want to kind of get rid of this right here. Appending HTML in code into an output stream is really not a good idea. Of course, you should really use templates. So I'm going to invoke a templating engine for me. And then the other thing I want to do is to use, data that comes from somewhere else. And I could hook up a database, but I don't want to do that just yet. Instead, I've got a little class in here called haiku. Scrape some haiku off the web. I'm creating a string array right here. And then I have a method called random that simply randomizes that string and returns it back. So I'll be using that as data from the database, if you will. So let's get started working with templates. And what I want to do is I'm going to come in here and say new directory or new folder. And let's call this views. We'll work with convention. Why not? Inside of here, I'm going to create a new file, and it's going to be a HAML file. And sure, I'll call it index. Why not? And inside of here, let's do a little HAML markup. If you never used HAML before, this is going to look strange to you. I'll kind of walk you through it a little bit. HAML's not really the point of the screencast, so I'm not going to go too deeply into how to work with it. However, I will be doing a screencast again shortly using Sinatra and HAML and SAS and all that good stuff. Okay, so really quickly, I want to output the doc type, and I use some shorthand HAML notation, which is 3 exclamation points. I also want to say here comes some HTML, and here comes a body, and here comes a header tag, and we'll do the header 1. Now, if you're wondering what is those percent things, why are you indenting? It's a really simple rule. If you use percent, as you see here, you're saying this is an HTML tag, not the necessarily, just an HTML tag. So the renderer is going to surround this with brackets. Inside here, it's going to surround body tag, and same with H1. Now, if you indent them, it's going to say, okay, well, everything that is indented below me, wrap, and then put a closing tag down here. You'll see all this when this thing renders. Hopefully it'll work. Now, if you want to put some inline code in, you just put in the equal sign, basically saying here comes some lovely code. What I want to output is one of my haiku poems right here at the top. So I think that would be quite nice, don't you? Okay, well, let's hook up 2 things. First, let's hook up HAML. We're going to need to access these things in my app class. And so if you're used to C#, then you would typically put in a using statement because you're going to use let's say another namespace. In this case, we don't need to do that. What we need to do is we need to say we're going to require another code file, and you just say haiku. You don't need to put in haiku.rb. It would know what you're talking about. The other thing we're going to require is HAML, and it's present on my computer as a gem. So if we just require it like we are here, then it will just show up, so it's okay. All right, so the first thing I want to do is I want to pull out a poem. So I'm just going to say poem, and I'll just say it's going to be haiku.new.random, and that'll pull in a poem for me. The next thing I need to do is I need to pull in this template text. Now I'm going to hard code this here, but of course you don't need to do that, but we can put rules for that in later on. So I'm just going to say template, and it's going to equal file.open, and we're going to go to views, and this is going to pull out index.haml. And then I'm just going to tell it to read that stuff. Great. So now we have the template. Now what we need to have is our engine. And so the engine is going to be HAML, and then it's going to be engine.new, and we have to pass it the template text. Great. So this is going to be what it's going to parse on the render command, which is coming up next. So let's just call this out, and we can say engine.render. And I need to tell it what scope it is rendering in. In other words, it can kind of run in its own little scope bubble, or well, it could run in the application scope. Again, that's just not really the point of the screencast, so I'm just going to tell it to run in new object scope, which is basically like saying just pay attention to yourself. And then I need to pass it the local variables. Now, I declared one called poem, as you can see in here. There it is. So I need to tell it what that value is. And so I do that using a symbol here, poem. And then I tell it this is the value for it, which is going to be this poem right here. Pretty much that's it. And now I just simply need to replace this output right here with the output. And that's it. I've just wired up a templating engine. Isn't that neat? Let's make sure it works. I hope it'll work. And there it is. Great. A giant firefly. That way, this way, that way, this, and it passes by. So if I refresh, that's great. But the best part is if I come in here and view the source, we now have proper markup right here. You can see how HTML body is indented underneath, H1 is indented underneath that. And, well, this is a bit of a problem, but we can fix that later on. But right now we actually have something functional coming together. Now that we have templates in place, our application is turning itself into a little bit of a framework, which is kind of neat. It's going down and searching out templates in which to inject data. Sounds familiar, doesn't it? Well, so let's take a look. Our application is working pretty well. I don't think we need this environment output. It's an interesting little test right here, interesting little exercise, I should say. Yeah, let's remove that for now, and I'll remove this using right here. And I think what I'm going to do is I'm going to rename this because it's kind of turning into a framework, and I'll give it a frameworky name. Call it Avery. Why not? All right, and let's refactor a little bit because right now we have one method, call, of course, and we're doing a bunch of stuff in here, and that's not very good for our budding little framework. So what I'm going to do up here is I am going to create a method, and we'll call it Hamel. And that's going to accept a template name and some locals. And what we can do with that is to invoke our Hamel template stuff. All right, so let's do this right here real fast. I'll pull this up here, and I'm going to reset this to the template name. Great, we'll set it to read. In fact, what I should do is I should go with convention here, so I'll just say views, and then I'll do some string work right there, views template name. Alrighty. And I could even just be cool about this and say Hamel. There we go. Because we're going to make sure that everybody that uses this thing is going to be going to views and then using Hamel. Why not? We're opinionated. All right, and so the template is going to pull it out, template, and we don't need to have this out variable anymore. And let's just make sure. And instead of poem, we're going to reset that right there. Okay. Well, we can call this now from down here. We can say Hamel, and then we'll pass in index. And then we'll set this to poem equals poem. Okay, and then we can set the variable out equal to that. All right, a little bit of refactoring. That should work. Avery will be pleased with his eponymous framework. Whoops. Oh, yes, forgot to change this now away from my app. Thank you, Shotgun, for telling us that. So we can refresh this. Boom. All right, that's feeling a little bit better. But I think there is probably a little bit more we can do. Because right here, you know, we're accepting a call to Hamel. But what if we send in a different URL? We're going to want to be able to deal with that. And since we've turned this into a framework, now let's expand it a little bit more. So I think what I'm going to do here is I am going to create an index method here, our initializer. Not an index, I meant to say initialize. And what I'm going to do is I'm going to use a class level variable called response. Set that to an empty string. And then let's create another method here. We'll call it get. And what get is going to do is, well, simply, I guess, just kind of lift out that getting logic and put it into a single method. Because, of course, we don't want to have this popped directly into our call method. So instead of that, we'll say get and locals and great. And inside of here, we can call Hamel. Just like that, because Hamel's our engine, and we can set the response equal to that. All right, getting there. Okay, let's kind of tighten that up a little bit. So now what we can do is just take this stuff completely out, because we, of course, don't want that. Call ideally should just return this array. All right, so then we can take response and send it down there. All right, well, if we run this now, nothing's going to happen because response is nothing. So as any framework should be, well, we should have an application on top of it. So I can do that now. I can declare my app, and we'll call that app. And then what I can do is I can get funky and I can inherit from Avery. That sounds a little strange, but I think we'll get used to it. So inside here, I can create another constructor. There we go. And I can say something like get index, and then we can say something like, oh, poem goes. All right, almost ready to run it. And oh, yeah, I got to make sure I reset this, and we'll double check. Whoops, and forgot to, of course, reset these values here because we want to be able to send in the variables and not hard code them. All right, I think we're about good to go. So let's come back over here, refresh it. Hey, it's the first web application built with the Avery framework. Well, he's going to be so proud. The Haiku app is pretty groovy, as well as my Avery framework. I'm excited about that. So as we're starting to see, working with Rack is resolving itself into a couple different usage patterns. First, we've built a framework, which is exciting. Then we built an application on top of that framework. But there's a third way that we can work with Rack, and that is the concept of middleware. And you've heard me talk a little bit about middleware already. What is middleware? Well, it's kind of a filter. If you think about it, you can shove these responses, as you're seeing that we're doing here, shove these responses and status codes and headers, other things, through other Rack applications that can alter it in some way, and then pass it off. So that's what I want to show you now, is a way that you can generate these little filter middleware bits to do your bidding. And then, once I'm done with this, we'll move on to showing you how you can use actual applications as middleware. It's all very functional. So, all right, what I want to do this is to change the name here, just so we know what we're doing. We're going to call this a haiku filter. And what this is going to do is simply going to take a response and shove on some haiku, which is groovy. And then I'm going to take out the Avery framework and initialize. I'm going to rework here so it accepts in an application. Because it's a filter, we need to be able to pass in an application, work with that application by setting it to a class instance variable here, and then also have our own call method, as you're going to see me build, and we're going to accept an environment. This is your typical rack middleware or application setup. Initialize, pass in an app, environment. All right, well, I'm going to drop in the code here really quickly for appending haiku onto the response. All right, here we go. And call, again, is extremely simple. I am simply checking to see if there's an application that was passed in. If there was, then what I'm going to do is pull out the response from that application and then append on my haiku. All right, well, we have an issue here, as I've talked about before, and that is that I am assuming that this is going to be middleware. Now, it could be. I've called it filter. And I could just say, hey, you know what? This is middleware. It's not designed to be used as an app. However, I want to safeguard against that, and just, besides, I can't show it to you unless it is app ready for being an application. So to do that, I have to say, well, if it's the first app, there's nothing being passed in. So I'm going to default this to nil. And down here, this is my nil check. In Ruby, if you're not familiar with this, any object that's nil returns a false. So this is a kind of a shorthand way of saying, hey, if we have an app, then go ahead and append on the response. Okay, well, that's simple enough. Now what I want to do is to use this as an application. I will just say haikufilter.new, and instead of having the pretty output as you see here, if I right-click and view the page source, you can see it's just dropping in some stuff. Okay, well, that's not really exactly middleware now, is it? Well, what I can do here next is to actually create an application like I did before. So what I might want to do is I will just say class my app, and I'll make this an Avery because I'm going to reuse my framework there. And then I'm going to, in the initialize method, all right, so there's our poem, Hello World. So playing with things as I should. All right, well, if I want to append on some haiku, just to be nice, I certainly could. Remember, all I've got to do is use. All right, so I can say use haiku filter. There we go. And now, if I refresh this, I get a nice little haiku. All right, well, there's a little bit of a problem here. I'm actually not going to address the way to get around it, but I should point out that our rendering is going off here exactly as we expect it to. But note here that it's appending on after this entire response. Now, there's ways to get around this. There's ways to use the response as an object and not just a string. In fact, that's what Rails does. It's what Sinatra does. And I'm going to talk about that in just a second. However, just be aware that what I'm doing here is just appending these values straight onto the response. Okay, well, let's just keep moving. I can actually make some more middleware. Why not? It'd be kind of fun. Let's make one called Massive. I like Massive. Massive is nice. And so I'm going to keep all the same everything. And what I'm going to do, instead of doing haiku in here, perhaps what I can do is just take the response and surround it with massive div tags. That should be fun. All right, 5.0 M. So now come back over here and refresh this. Yikes! Well, that's pretty loud. So let's take a look at what happens. So if I view the page source, well, it's surrounded absolutely everything. But it's weird. Didn't I just say that it would be appended on? I mean, you would think that if I did a use there, that it would just kind of append on the div and nothing would really happen. So what's happening here? How is this chaining actually working? Well, the way this is orchestrated here is by a thing called the builder. We talked a bit about the builder before, but when you issue these method calls that we looked at in source a little while ago, what builder does is just simply append them in reverse order. Run is sort of the start, of course, run. And what it's going to do is create the rack application. It's then going to take this rack application and shove it into the next one in line, which is the next using statement right above it. And then it's going to shove it into the final one. So this all happens in reverse order. And of course, everything that you do highly depends on how you arrange your filter and how you append your text or do whatever you're doing. And as we're going to see in just a moment, the builder can arrange things, but it doesn't necessarily mean that's how it's going to display on screen. Let's continue on with our example to see a little bit more about this chaining. What I'm going to do is I'm going to add a little class here called quotes, because, haiku is nice, but let's add some quotes. There we go, and quotes works just like haiku, except instead of little haiku poems, we're getting some Willy Wonka philosophy. Okay, well, let's add something else too. I kind of miss my little environment out stuff because, that's a pretty informative filter. So let's drop that in too. I'm going to give it its own class file. All right, welcome back to an old friend. Here's our environment out. Same kind of format we've been working with. And, well, here it is. There we go. Whoops, I don't even have a quotes app, do I? Let's create a quote filter. And I'm going to do this just like that. And we'll call this a quote filter, and the quote filter will work exactly the same as haiku, except what I'm going to do is say quotes new random. And again, it has the exact same random method in there. All right, quotes new random, that looks like it's good. So instead, of course, using quotes as a class, I will use the quote filter. Great. And then why not use environment out? Again, we need... No, actually we do. We just got environment out. Yep, that's a rack app, so we can go straight in and say use environment out. There we go. All right, well, let's see what we got now. We should get a whole mess of weirdness on our screen. And I refresh. Yikes! Okay, let's get rid of massive because massive is bugging me. Because massive, again, is wrapping everything that comes before it. So we'll get rid of it by commenting it out. There we go. Much better. All right, so let's once again see exactly how this is laying itself out. Hello world is myapp.new. The next thing I'm asking for is environment.out, and here it is, appended in. Next thing I'm asking for is a quote. Quote. Final thing, I get my haiku. It's the last thing here. If I move haiku to come right after myapp.new and I refresh this, well, we come up here and we get the nice action right there. Now, if I want to make my application's output massive, I can do exactly that and refresh hello world. All right, well, that was a quick tour of chaining middleware together. One thing I want to address is the response. I'm actually being pretty negligent here. There's better ways of dealing with response. So we've managed to chain our middleware filters together. But we have a bit of a problem because if we view the source here, we can see that our filters are actually disabling completely our framework. So if you recall, our little Avery framework is using Haml to render out this really nice, pretty HTML. But we're ruining it by, surrounding it with massive font styling. And that is really not behaving like a good filter. So there's ways around this. Primarily, the higher level frameworks like Avery should really implement a way to grab the response, even if it's a filtered response, and then inject that response into the output of a template. In this case, I'm kind of ignoring it. I'm just letting the response go run free. But that's not really something that my framework should do. And indeed, most frameworks built on top of Rack, like Rails or Sinatra, don't do that at all. And so to understand that, first you have to understand that Rails from 2.3 onward and Sinatra, Camping, a few other Ruby-based frameworks, they don't just send around strings in this response. What they do instead is they make a full-blown object out of response, has a thing like response.body, that it will then inject into an output template such as Haml, like this. It will not just accept string. It'll only accept response.body, and then it works with that later on. Okay, well, we could do that if we wanted to. We could come down here and say, well, all right, so the Avery app, in order to conform to what the rest of the other frameworks are doing, needs to have response.body set up here. It needs to be an object, and that's what we're going to do. But that's not a very good way of working with this either, because we're assuming that our Avery filter, or excuse me, our haiku filter will always be used with something that implements response.body, and that is not the standard. So we're kind of stuck. Or are we? Well, we're, thank goodness, not. The good news is that we're not stuck. The people who wrote Rack kind of took this into account, and they said, well, the response really it needs to be able to be worked by more than just Rails, of course, more than just Sinatra. It shouldn't have to have the specification where it's got a thing called a body on it. Instead, we are going to make sure it responds to a single method. So in the same way that Haiku filter here, this rack app, has to respond to a call method, well, response needs to respond to an each method. Each is an iterator. And so what's going to happen is that rack is going to call each on our response. Whenever it gets it back, it's going to iterate over it. Now, if it's a string, that simply means each is going to go over each little character inside that string and build it to the output. That works out just fine with what we're doing here. However, if we're working with Rails or Sinatra, we're going to fail completely. What we should do is to work with rack and what it expects, and maybe refactor our Haiku filter a little bit to work with each. Before we get rolling with the refactor here, I want to address people who might not be familiar with Ruby and kind of reiterate that Ruby is a dynamic language, and the rules for doing certain things with Ruby are completely different than working with C# or Java, which are more statically typed and compiled languages. For instance, what I need to do now is implement an iteration routine. Now in Ruby, the rules for doing that are a little bit different. So if we're working in C#, for instance, and I wanted to work with an object that I thought should have an enumerable, I would ask it. I would say, hey, is the type of this response, is it of type IEnumerable? And if it was, then I would go ahead and cast it and then grab the enumerator and work over it. In Ruby, that's a little bit different. What you do in Ruby is, and if you can see this by taking a look at the RDoc for the class object, believe it or not, object is a class in Ruby. There's a lot of things you can do in here, but the one that we're looking at is respond to. And what you can do is you can say, hey, will this object respond to this method or property or whatever? And so we can ask it that completely. We can say if, and we can say response.respond to, and if you're wondering why a question mark, it's just a Ruby idiom that means what's coming next is a Boolean true or false. And we can say if response.respond to each, then go off and do some stuff. In this case, that means I can iterate over the response. Well, I don't even need to do this test because we know this about rack already. It expects and requires and demands that response responds to each. So, given that, we can now work with our response here so that we can append in this no matter what that response is, even if it's an action controller response or some type of response sent in from Sinatra or some other framework that comes later on. So all we know is that our response needs to work with each. Now, we could sit here and we could iterate over the response. We could say, well, let's just do this. We could say response.each and then iterate over that, and we can say content here and then append in our content on top of it or in the middle of it or on the, that's just not fun. We could do that, but it gets really kind of hairball, and it's probably not the easiest thing we should do. Inside here, it's kind of messy. Instead, what we can do is a little bit of a trick. We can implement each on our filter itself. So to do that, we can say def, and we'll create each. There we go, each. And then each, as you just saw me do, must take in a block. And so a block, if you're coming in from C#, is simply a delegate. In this case, it's just a block of code. So if you can think of this, if you're a C# programmer, as a delegate method created on the fly, and you can simply call that. So what I can do is I can just say block.call, and then I can take this and append it in. And then, great, so now I have this this being called and appending into each, but then I'm still sort of stuck because our response right here is, well, it's kind of being orphaned. So what I'm going to do is I'm just going to do this. There we go. All right. And probably not a good idea to initialize it. In fact, I'm going to take the step here of making sure our filter has an app. If it doesn't, it's going to throw. That's okay. And that's going to take this out right here. And now what I want to do actually is I want to kind of be a good programmer here and work with more than just the response. And what you can do, this is one of the neat things, is if a method returns an array, you can actually stack the variables. So I can do that. I can say status, headers, and then response, and I'll say at response because that's going to make it a class level variable that I can use in my other method down below. Status, headers, response, there we go. And then I can take this out right here. And good, we're almost there. And then I next up need to go to at response, and I am going to call each on that, and then I'm just going to pass my block back in. Now you might be looking at this going, what in the hell are you doing? Stay with me, I'm almost there. Okay, well, the other thing I don't certainly want to do is, since this is a filter, I don't want to have the status code being sent back by my filter. I also don't need it to do any of this stuff. In fact, this should just be a simple pass-through. So I can remove that right out. And there, almost getting there. What I need to do in here, let's just do this and make sure this is returned. There we go. Is somehow make sure that this each is called, because this each is going to call the block, which is going to insert my haiku, and then it's also going to just kind of call the block on response, which is exactly what we want. It's going to call each on response. So how do I do this? Well, remember, each is called for every single response. I want to make sure that I get the each called for a haiku filter. So what I can do is just put in self right here. A little bit of trickery, but look how that cleans everything up. Okay, let's slow down just a second. I have a feeling that maybe I went a touch too fast. So let's take a little more time with this code, because in here is a concept that is very important if you're going to be working with rack. So I want to take a second and explain this a little bit more. So what we're looking at here is a very basic rack application. All a rack application needs to have is a call method. That is it. Now, the whole point of a rack application is to build up the three little amigos there: status, headers, and response. Now, eventually, that response is going to be built to a point that we can just hand that back to a browser. The only requirement that rack has is that whatever you do with this response, it needs to be enumerable. You need to be able to loop over it. In Ruby parlance, you would say it needs to respond to the method each. That's how you loop over things in Ruby. You say something like array.each do, and then you do a thing. So that is how we're building that response as we work with rack. So maybe to understand this, we should take a little tour into the source code of rack and see how use actually works. When you queue these things, what's going on? All right, so once again, here we are at GitHub at Christian Newkirken's source code. So let's scroll down. I am inside Builder. Builder is the thing that sort of takes all these little middlewares, all these little rack applications, and sort of stitches them together. So if we come down here, there's a couple of things that we should notice straight off the bat. First is, here are the methods that we have been using. Well, here's use and here's run. But notice that it's working with this little variable called ins. What the heck is ins? Well, we can find that out if we come up here to initialize. Remember, this is the constructor. Ins is just simply an array. Now remember, in Ruby there are no types, so it can be an array of just about anything. Okay, well, here is the method use that we have been using. And, well, as you can see, what's happening here is middleware is being passed in. That's what this is right here. And then we can also pass in a few other things. We haven't really done that, but let's just move on for now. Pretty much what's happening is this little symbol just means append. So if you're thinking of C#, this would be like, list.add. This is notation for basically shoving something into an array. What's happening here is, well, essentially our application, our middleware that's being passed in, is being appended into ins. Same thing happens with run. Well, now that we have that, what happens then? So great, we queue all those things into an array. We kind of figured that out. First in, last out. That's what we've been seeing. Well, you know, the interesting thing about Builder is, look at that, call. It is a rack application in itself. So what rack is going to do is it's going to invoke the Builder. The Builder is going to go, it's going to gather the things out of the rackup file that we've said to use, using use and run and so on. It's going to queue them into an array, and then, well, rack is going to call on Builder. And that thing is going to then call a method, as you can see, to app. Long story short, this is Ruby looping over that and then calling each thing in line. All right, great. So we kind of figured that out from our previous things. It's queuing up these little racklet applications, call them racklet, why not? And then it's invoking call. The whole point of invoking call on those little applications is to build the response. Once that response is built, Rack is then going to iterate over the final response and basically hand it off to a browser. All right, so now that we have that level of understanding, let's go back to our code. All right, so when Rack iterates over our response, in here you can see we are handing self back as the response right here. Well, self, fine, it can be anything. It just needs to respond to each. Self, if you're from C# or Java, is the same thing as this. It's just handing back the instance of this application. Rack doesn't care what it is. All it needs to do is go to each. That's what it's going to do. Once it hits this, it's going to fire each, and then it's going to kind of pass over it. Well, down here, we're just appending out our stuff, and then we're handing off to the response that was handed to our class, and then saying, okay, all we want to do is this part, hand it now off to our calling application, which is this guy at response, which we set up here. Remember, we pulled it out of the calling application. We're calling each on that. Okay, well, that's about the best explanation I can give you. I'm not a Ruby expert, but at the same time, I think it's pretty important to understand exactly how this code works. Okay, I've reset massive and I've reset my quote filter. And if I come over here, you can see the environment out is reset as well to implement this pattern. And let's go and refresh and bring it over. Look at that. It works, sort of, except that it's completely reversed. What happened here? Well, let's take a look. What's the output? We've got quotes on the very top. Then we've got our environment out, little filter here. And then we've got our haiku. And finally, we have our templated app output. What's going on here? How does this work like this? Well, to understand this, we got to go back over to our code and scroll down for our builder stuff. And if you recall, if you use, you call the use method on builder, which that's what this is. This is a builder file, a rackup file. You call use. What it's going to do is going to queue the little rack application. So it's queuing this as an application into a collection, if you will. And it's kind of loading everything up. And then when you run when you run the application, it's going to start here and work its way backwards. It has to, because this is the app, and that app is going to be handed to this filter. Then the results are going to be handed down here, down to here, down to here in a big, long chain. Well, what we were doing before is we were appending to the response in the call method right here. So if you recall, call is what's called when the application is fired. So myapp.new is called, and a response is written, hello world. Then massive is called, and it does its thing, which wraps hello world, and so on. Well, that's not what we're doing here. Call simply returned self as the response. So what happened is builder went down, executed call, got to the very end, and said, okay, let's take the response and render it. And when it rendered the response, it fired each on the response, which is this guy right here. So response, if you remember, is this. We returned self. So when it fired each, it just iterated over it just like any other list, and therefore started here, called each, called each, called each, called each, done. That is why it's reversed. Now you might be looking at this going, dude, this is just a little gross. Why would I ever put all this logic into one file and then call run at the bottom? It just doesn't seem very tight. And you're right, it is gross and it's not terribly tight. So let's clean this up a little bit with some configuration. One of the things I want to do is rename this file. app.ru, it's fine, but RU file is more like orchestration or configuration. So if you have a file like this, you want to call it config.ru. And you certainly do not want to have all these class files in it. Instead, what you should have is class files, per class. So let's split these things out. Okay, all set. Clean this thing up a lot, as you can see. And, this is what a config.ru file should look like. You're telling Rack what it needs to use to get started. We've got all our requirements up here. We split out every single class into its own file. Our model is stuck here in where it should be. Haiku, quotes. Great. All right, well, now that we've named this thing config.ru, we're relying a little bit on convention. That's exactly what Rack looks for by default. And to see this in action, I've opened up the terminal here. Let's restart our application. We don't need to restart it, but I want to. So to do that, all you got to do is type in shotgun. Remember, shotgun is our app starter. Go. It found the config.ru file, and it's happy. So we come over here, and we can restart. And look at that. It works. Well, that's groovy. Okay, well, that kind of shows how you can use Rack for middleware. Let's get a bit more sophisticated with what we're doing here. Middleware doesn't necessarily need to be in the form of a response filter, if you will. It can also be sort of a sub-application. You see this a lot with Sinatra. So let's go back over here, and what I'm going to do is I am going to just remove all of these things, and let's take out all of our filters, and we'll just require our little application here. There we go. And so let's refresh this and make sure that we haven't destroyed anything. Hello world, great. So now what I want to do is let's go back into our app here. I'm going to reset this to output a poem from our haiku. And so I'm going to say haiku.new.random. And because we're doing that, of course, we need to come up over here and require models haiku. Great. All right, so this kind of resets it to where we were. Whoops. Okay. That's because it's not models. It's model. All right. Fail. I love you too, shotgun. There we are. All right. Well, that's working. Let's just view the page source to make sure everything's getting injected right, and it is. Awesome. Okay. So let's do something a little bit different here. We have my app. Let's recall or rename this haiku app. And what I want to do here is I actually want to create another one. Let's call it quotes app. And just for the sake of time, I'm going to put it right here. Quotes app. There we go. And instead of haiku, I want to do quotes. Quotes.new.random. Great. And then I'm going to have to require quotes in here. Okay. Okay, so now I have two applications based on the same framework, my Avery framework. What good does this do me? Well, now what I can do is I can actually split things apart inside my config.ru. I don't necessarily need to say run. I can do something a little bit different. I can actually use the map command. So map is something that Builder uses where it'll map a URL to a particular application. Rather than just saying run and use, where use is more like a filter, run just says here's your app. You can use map to actually map a URL to an application. So what I could do here is I could say map, and then I could say let's pass in, we'll pass in by default that, and we make a block here, and then we'll just say run, and it's not my app, it's haiku app.new. Great. What if we wanted to do something different? I could say map quotes do, and then I could say run, and then quotes app.new. There we go. All right, so we are requiring app.rb. Inside app.rb is the definition for quotes app. We should be good to go. All right, so by default, if I refresh this, great, that works. But what happens now if I go to quotes? Woohoo! Hey, look at that. That's kind of neat. Well, I can keep going with this if I wanted to. I can come back over here to my config.ru, and if I wanted to be explicit about this, I could say haiku. And I could reset this to haiku, and come back over here, and then make sure that this works. Haiku. My grumbling wife. My wife doesn't grumble. My wife's awesome. Give me another quote. There we go. In my old home, which I forsook, the cherries are in bloom. All right, well, that's a neat trick, but what does it mean? Well, if you take a look at this, what we've just done is to use Rack to orchestrate sub-applications into a bigger application. You can let that rattle around in your brain a little bit. You saw how we kind of appended these little filters together. Well, you can also append these higher-level applications together, just like we've done here. Now, in this case, we've used our Avery framework. Come back over here. Now, admittedly, Avery framework isn't, well, terribly functional as of yet, but what if it wasn't an Avery framework? What if it was another framework that was Rack-based? Something like Sinatra. You could use Sinatra, and you can have a bunch of little Sinatra apps. You can put them all together and make one big fat one. That's pretty cool, don't you think? What if you're using Rails, though? Well, still, you can still use other Rack-based middleware. So if I wanted to squeeze Haiku into a Rails app, I sure could. Let's take a look at how. So let's have a little fun with our Rack middleware and plug it into another Rack-based application. And as you've heard me mention before, Ruby on Rails as of version 2.3 now supports Rack, so you can plug any Rack middleware that you create into a Ruby on Rails app. So here in front of me, I have the Tekpub website source code. And don't tell Avery I'm doing this, but I think it needs a little Haiku love. So what I'm going to do is plug in a new directory here, and I'm going to call it middleware. And of course, I need to spell it properly. All right, and inside of middleware, I am going to add a new file, and let's call it Haiku. And then I'm also going to call it Haiku filter. There we go. All right, so now what I can do is go back over to our old application in Haiku here and copy and paste it. Here we go. Boom. And it goes. And then I need to do the same thing for the Haiku filter. Copy, paste, in. All right, well, since we're not sticking this Haiku file into the model directory, I'm just going to kind of pop that out right there. Great. All right, and so now, hey, that's all we need to do there. Next thing I need to do is to wire it in to Rails. And to do that, I'm going to hit Command-T, head over to environment.rb. Inside of here, I need to do two things. First, I need to plug in the middleware. And you do that by saying config.middleware.use, and then I'm going to give it the name, got to give it the class name, Haiku filter. All right, what that's going to do is it's going to go out and load that thing, and then it's going to use it just in the same way that we put use down in our rackup file before. It's just going to plug that filter right in. All right, well, the other thing I need to do is middleware is not a directory that's supported by Rails. In other words, it won't find that file. And one of the neat things that Rails does for you is kind of resolve your using statements and so on. It loads files by default. You just have to tell it, hey, besides your convention-based stuff, use my stuff too. So in this case, I'm telling it to, off the root in the app directory, I want you to load up all the files inside of middleware for me. Awesome stuff. Okay, now that we've done that, last thing we need to do is to come over to our server, which is currently running our Tekpub website. This is up on localhost. And if I refresh this, you can see it's all the same code, all the same HTML, nothing terribly different. But what I need to do is to come over here and close this thing down. And so I do that by hitting Control-Z, and it's stopped. Great. All right, let's reload our app. And look at that. Woohoo! We have a little Haiku being injected into our app. Okay, so you might be thinking, why in the world would I ever use such a thing? And in Rails parlance, this is called Rails Metal. It's where you kind of plug in these little bits of Rack-based applications that kind of sidestep the entire Rails framework. So the way I went about it just now is a kind of brute force way, and there's a better way to do it. So let's show you that. Why not? And so inside of here, I can simply type in script generate, and then I can say metal. And then let's just call this Haiku. Yeah, we'll do that. All right. There it is. So it created a couple things for me, app metal and app metal haiku.rb. So I can come in here and I have a brand new file. And so inside haiku.rb, look what I have. So now let's do this the right way. So I can not move my filter. Let's call this, let's rename this here, and I'll just call this Haiku data, just so we don't mess with the existing Haiku thing. There we go. And what Haiku did for me is, you can see right here, if the path equals this, so now it's letting me dictate by path in my application the route to my middleware. So great, and then it's actually doing a response for me. Well, of course, that's not what I want. What I do want is to use my Haiku stuff, so I'm going to require Haiku data. There we are. And then what I want to do is, instead of hello world, what I'm going to do is respond with, and take this out, Haiku. Let's call this data. I'll change that .random. All right, let's go back in, and I'll change this class name to this. Great. And now I can ditch this because I don't need it anymore. Rails is handling this for me. And I'll remove this file and move it to the trash. Great. All right, so come back over here, and there we are. Haiku data, new random goodness. All right. This also means that I need to go back in here to environment, and I don't need to jam in the middleware anymore, and I can take this out, and I can take that out. Okay. Well, again, why in the world would I do something like this? Well, it depends. If you're just going to be serving up very, very simple information from your Rails app, perhaps it's just a count of users, for instance, or just some simple stuff. You don't need the entire framework for the request. That's where Rails Metal comes in, and it's pretty handy. All right, so there we are. So I should be able to return that, no problem. And what I need to do is, of course, stop and restart the server. And let's do that real fast. Whoops, got an error. That's not good. All right, so what did I do wrong? And if I take a look at this, it says, let's see, haiku data. Yes. Anything in the middle directory here is going to be treated as if it's middleware. So what it's trying to do is it's trying to just call this. It doesn't implement call, so it's having a problem. I'll just move that down to models. I'm good with that. So that means that inside of here, I have to say requires models haiku data. That should work. It might not. Let's just see if I refresh this. Hey, look at that. All right, so our app starts, and if I go to haiku, hey, what do you know about that? So now we're in the interesting position that we understand Rack. We can actually bend Rails to our needs. We can sidestep Rails if we want to, just by using a Rack bit of middleware. Kind of opens up the possibilities for a lot of interesting scenarios. You can take a look. You can see all the files that are in it. So now all I need to do is to say, great. Oh boy.